So hello and welcome to new video series. So in this video series we'll be discussing what RabbitMQ is. So talking about RabbitMQ, it's a message queuing software also known as a message broker or queue manager. So RabbitMQ is a message broker server, and the goal of using RabbitMQ is to let our application delegate actions in case they are time consuming or if we want to parallelize them. So let us see why messaging is required or why do we use message broker service. So here I'll be taking a general e-commerce scenario and how that's implemented as well. So in an e-commerce platform scenario, RabbitMQ can be utilized to handle communication between various components of the platform. So there might be multiple components of the platform. So here let us see how RabbitMQ is applied. So as we can see, there is an e-commerce platform. So this will be regarded as the producer. So this producer is the central e-commerce platform that is responsible for managing product listing, customer orders, inventory, and other operational aspects followed by the e-commerce. And we have the consumers. So the first consumer will be e-commerce website. So the e-commerce website will be built using PHP programming language, and the e-commerce website developed using PHP is the primary interface for customer to browse, search for product, and make purchases. So since it's a website, so it's a primary interface using which we can interact with the e-commerce platform, and it connects to RabbitMQ to receive message updates on new product arrival, stock availability, pricing changes, and order processing status as well. So in this way, these kinds of messages are consumed by this consumer. Then we'll be having mobile app. So this will be built using Java. So the mobile app serves customer who prefer shopping on their smartphones. It is developed in Java and communicate with RabbitMQ to stay informed about product changes and order updates as well. Then we'll be having order fulfillment system. So this will be built using Python. So this system handles the processing and fulfillment of customer orders, including managing inventory and dispatching products as well. It subscribes to a RabbitMQ to receive new order notification and stock availability updates as well. Then we'll be having payment gateway integration. For this we'll be using C#. So the payment gateway integration developed in C# processes payment and ensures secure transaction as well. It connects to the RabbitMQ to receive order payments, notifications, and updates. Then we'll also be having customer support system. So we'll be using Ruby for this. So a customer support system that handles inquiries, complaints, and support tickets from customer. It subscribes to the RabbitMQ to stay informed about the customer order and issues. So this is not what we'll be implementing, but this is a general e-commerce platform scenario. So in this scenario, RabbitMQ acts as an intermediary for exchanging information between the platform and its various consumer. So in an enterprise setting, we could see there will be multiple kinds of consumer, and there might be also multiple producers as well. So when there are changes to the product listing, price adjustment, new orders, or updates on stock availability, the e-commerce platform sends message to the RabbitMQ, and the RabbitMQ then distributes these messages to the appropriate customers, allowing them to take necessary action and update their respective systems. So let us see the e-commerce platform challenges and how these challenges were overcome by using RabbitMQ. So the first challenges will be multiple business system. So these are the various software application or components that belong to different part of our organization. They could include inventory management, customer relationship management, order processing, and other systems that need to communicate and share data. So this is one of the challenges on e-commerce platform. Then we'll be having need to share data in real time. So real-time data sharing means that these business systems require immediate access to the updated information. For example, when a new order is placed, it should be immediately visible in the inventory system and to the customer support team as well. And we have different operating system. So the business system might be running on different operating system. So for instance, some could be on Windows, other could be on Linux, and so on. And the other challenge is different language. So as we saw on the previous e-commerce scenario itself, so there are different languages So each system may be developed using different programming languages and technologies. For example, one system might be written in Python, another might be on Java, and the third might be on C# or Ruby. So this is also one of the challenges faced by the e-commerce platform. Then we have the other challenges, that is need to scale. So the scaling might be performance wise or it could be the feature wise as well. So scalability refers to the ability of the system to handle increased load or growth. So in this context, you need to scale both in terms of performance, handling more data or messages, and feature wise, like adding new capabilities to the system. So this indicates a dynamic and evolving environment itself. And the final challenges is using database as messaging does not scale. So using a database as a messaging solutions refers to the practice of using a database to pass message between systems. This can be a bottleneck as the volume of data and the number of system grows. Databases are not designed for real-time, high-throughput message passing, and they lack many other features that are dedicatedly provided by message broker services. So to address these kind of challenges effectively, using a dedicated message broker like RabbitMQ is a recommended solution. RabbitMQ can ensure real-time data sharing, cross-platform compatibility, scalability, reliability, feature expansion, and efficient decoupling of system, which makes it ideal choice for managing communication and data sharing in a complex, diverse system environment. So the solution, let us see the solution for all of these challenges. So the solution will be AMQP plus RabbitMQ. So AMQP is a advanced message queuing protocol. So let's discuss regarding AMQP. So here we can see it is advanced message queuing protocol. So AMQP is indeed an acronym for advanced messaging queuing protocol. So it is designed for efficient and reliable message oriented middleware, making it suitable for building distributed and complex system where different components need to exchange messages. So it's a industry standardized open protocol. So AMQP is an open standard protocol, which means it is not controlled by a specific company or organization. It is maintained by a community of developers and is widely adopted and accepted across various industries and applications as well. So this nature of AMQP ensures interoperability and a level playing field for all. Then we have wire level binary protocol. So AMQP is a binary protocol, meaning that messages are encoded in binary format when transmitted between systems. This binary representation is more efficient and compact than the text-based message format like XML or the JSON file format, so making it well suited for high-performance messaging as well. Then we have well-defined message model. So AMQP defines a clear and standardized messaging model, including the concept of queue, exchange, publisher, subscriber, and routing. This well-defined model makes it easier for developer to build systems that can communicate effectively using the protocol. In essence to this, AMQP is a powerful and versatile message protocol designed to provide a consistent, efficient, and open method for systems to exchange data and messages, which has made it a popular choice in wide range of industries and application as well. So this is the AMQP message extraction architecture. So there will be producer, and we'll also be having exchanges, and we'll be having queues, and we'll be having consumer. So the producer passes the message to the exchange. Then the exchange, based on the types of exchange, will be passing the message to the queue. Then the queue or the message stored in the queue will be consumed by the consumer. So the first one we could see are the producers. Then we'll be having a channel based on which the exchanges takes place. Then we'll be having a queue, and there will be a channel established between the queue and the consumer as well, and based on that the consumers will be consuming the message. So let's see the RabbitMQ messaging model. So there will be a producer, and we'll be having a platform like RabbitMQ for message queuing. And as I mentioned, it will be requiring exchange. So RabbitMQ is built on top of AMQP itself. So all the base understanding of AMQ is very vital for the understanding of RabbitMQ. So there will be having exchange, and we'll be having a queue, and there will be the consumers. So the producer passes the message to the exchange, then based on the exchange type it passes the message to the queue, and whenever consumer is ready to consume the message is then extracted or consumed from the queue itself by the consumer. Let's understand what exchange is. So as I mentioned, there are multiple types of exchange. So let's get a deeper understanding regarding exchanges. There are four types of exchanges. So the first one is direct exchange. Then we have fan out exchange. Then we have topic. And the last one we have is header. So these are the four types of exchange. So talking about direct exchange, or direct exchange route message to the queue based on a routing key. If the routing key in a message matches the binding of a queue to the exchange, the message is delivered to that queue. It is one-to-one relationship between the routing key and the queue. So direct message will be consisting a routing key and based on which the message will be routed to the queue. Then we have fan out exchange. So a fan out exchange broadcasts message to all the queue that are bound to it. It is one-to-many relationship, meaning that a single message sent to a fan out exchange is delivered to all the connected queues. Then we'll be having topic exchange. So a topic exchange routes message to the queue based on the pattern of routing key. Routing keys can include wildcard, that will be asterisk and hash, to match one or multiple words in the key. This allows for flexible and powerful message routing based on the pattern. Then we'll be having header exchange. So a header exchange uses message header attribute key value pairs for routing instead of routing keys. You can specify complex condition using header attribute and the message is delivered to the queue whose header attribute match the criteria. So let us describe or discuss regarding the each exchange and how the exchange is done. So let us see the direct exchange. So this will be the direct exchange kind of architecture. So here within direct exchange we can see a queue is attached or binded with the exchange. So for binding it will be having a binding key, and as we can see the message consists of a routing key that is ABCD. So the direct exchange, after the producer passes the message to the exchange, it will be transferring to the queue based on the routing key and the binding key. So as we can see the Q1 is bounded with the binding key ABCD and we have routing key ABCD. So this will be matched. So based on which this message will be transferred to Q1 and then the consumer associated with it will be consuming the message. And if we had a routing key that is equivalent to PQRS, the message will be sent to the Q2 and the consumer will be consuming the message from Q2 accordingly. So this is the general direct exchange, and as I mentioned earlier it will be using a routing key for exchanging or transferring the message to the queue. So then we have fan out exchange. So as I mentioned, it broadcasts message to all the queue, so it will be one to many. So if there's a message, and talking about fan out exchange, it does not require routing key to be added over this. So based on this the message will be passed to both the queue. So as I said it will be one to many relationship as we can see on the figure itself. So yeah, I hope fan out is clear to you. So no any other parameters are required, just the message, and it will be transferred or broadcasted to all the associated queues. And we do need to bind them, but binding key is not added here, so please keep that in mind. Then we have topic exchange. So as I said, topic exchange route message to the queue based on the pattern of routing keys. So here we can see there is a asterisk and there is a hash. So the asterisk represents one or more and hash represents 0 or more. So let's see an example of message. So here we can see there is a routing key associated with this message. So it consists of routing key that is abcd.org, and as we can see it matches the routing key with the binding key and also with the wildcard as well. So here we can see the binding key is set to abcd dot asterisk. So as I said, asterisk is for one or more. So let's say we have a message with routing key abcd.org. So this is passed to Q1 as it is bounded with binding key abcd dot asterisk. So let us say we had a message with abcd.com, abcd.in, abcd.np or any kind of thing. So this will be passing to the Q1 because the wildcard is getting matched according to the binding key. So it's similar to direct exchange, but it consists of wildcards. So I hope this is also clear to you. Then we have header extents. So a header extents uses method header attributes key value pair for routing instead of routing keys. So this could be a header, and here we can see a header consists of message or attribute, so that will be key value pair. So the key is name and the value is set to Nepal tag, and as we can see the binding can be made using argument. So here the argument is set to name equals to Nepal tag. So based on this message will be consumed by Q2, and as we can see header equals to binding argument is the pattern matching that it will be doing. So yes, in this way header exchange can be done. So now let's discuss this architecture over the demo itself. Okay, so let's get started with the RabbitMQ configuration and installation on Ubuntu server. So as we can see, I have a repo here. So the repo name is RabbitMQ producer consumer, and here I have the code for producing the message and consuming the message. So it's written using Python, and there is a readme.md file. So if you are trying to follow along the installation for RabbitMQ using this video, you can follow along with this readme.md file. So all the installation steps and all the steps that I'll be carrying will be added here. So for running our RabbitMQ, we need to create an instance. So I'll be creating an instance over AWS. So currently, as you can see, I am at Ohio region. So my server name will be RabbitMQ, and I'll be using Ubuntu image, and I'll be selecting T2 medium, and for the key pair I'll be selecting the key pair with the name RMQ. So other things as it is. So I'll be creating an instance and we'll be starting the installation and configuration of RabbitMQ. So let me go to the instance section, and here we can see one is terminated and another is on pending. So RabbitMQ server is on pending. So if I go here and instance state, so if we see the instance state, so there are multiple states. So that might be running, that might be pending, that might be shutting down, that might be stopping, that might be stopped, or that might be terminated. So in order to run our instance, it needs to be on instance state running, and it will be accessible as well. So as of now we could see it's on running state, so we can connect to this instance using the same AWS console. So using AWS EC2 instance connect, we'll be connecting this, and the username will be Ubuntu for this one. Okay, so we are successfully logged into the server. So let me clear this and let me first run an update. So before that, let me log in with root user. Let me clear this, and so let me update the system first. So looks like the update is almost successful. Then we'll be installing the prerequisites, so that will be including Python, since we are using Python for creating and consuming the message. So for that, let me install sudo. So I am logged in as root user, so apt install Python 3. So here we can see Python 3 is already the newest version, 3.10.6. so let me check the version itself here. So we will see the Python version is 3.10.6. so let's go back to our code, and we could see these are the steps. So let me first run this step. Okay, so it will be installing crawl, GNU-PG, and transport STPS. Okay, so it's done. Okay, so it's done. So let me go back here, and we'll be adding the repository for signing keys. So this will be adding keys for RabbitMQ, Erlang, and RabbitMQ package cloud as well. So let me paste this here. So it's been done. So we'll be creating a file at this location. Okay, so let me open inside the editor, and we need to paste this. So these are the same keys that we just pulled or downloaded. So let me paste this here. Okay, so it's done. Now let me update the system. And also we need to install the required Erlang packages. So let's copy this and paste this here. So after this packages will be installed, we'll be finally installing the RabbitMQ server and its dependencies. So let's wait for some time for the dependencies installation. So it's one of the popular tool that's been used by the IT organization or enterprise itself. So I think having a proper understanding of RabbitMQ will certainly be helpful in the further go itself. So let me install apt get install RabbitMQ server -y and dash fix -missing missing. So this will be installing the RabbitMQ server. So we can check the status of RabbitMQ server after the successfully running of this command. Okay, so let me clear this and let's check the status. Systemctl status RabbitMQ server. So we could see it's on running state. So we are good to go. Let me clear this and let's go back here, and so we are good to go. Now let me do one thing. Let me go to the EC2 instance section and let me open the port for RabbitMQ. So by default RabbitMQ listens on port 15672. So I need to add the port here so that my console will be accessible through that. So for that, let me go here and edit in bound rule, and within this I'll be adding another rule that will be 15672, and this will be for 0.0.0. so the security group is added. So before that we need to do one thing. So we need to also enable RabbitMQ management console. So by default RabbitMQ provides certain plugins. So here we can see there are multiple plugins that are available. So we need to run one of the plugin, or we need to enable one of the plugins. So for that, RabbitMQ RabbitMQ -plugins enable, and that will be my RabbitMQ management. So it will be enabling the RabbitMQ management plugin. So looks like the plugin is enabled. So let me go back here and let me copy my instance IP address. So for that, let me go to the EC2 section within the instance. So RabbitMQ. So for this, under networking, we will see the IPv4 address associated with this. So let me paste this here, and 15672. So here we can see RabbitMQ management is getting listed here. So by default, we'll be having a username guest, and password will also be set to guest. User can only log in via localhost. So this can be accessed only by the localhost. So we need to create a user so that it will be accessible elsewhere as well. So for that, let me go back here and let's create a user. So for this, let me clear this, and in order to interact with the RabbitMQ, so we need to run this RabbitMQ So since it's a long command, so I'll be setting the alias for this. So rm or rq. So now on, if I use rq, it will be automatically recognizing it as RabbitMQ. So I'll be adding user, add user, and I'll be adding the user with the name Sekhar, and password will be password itself. Then let me go to RabbitMQ set user tags. So this will be setting the user with the tag. So it will be my rabbit admin administrator. So here we can see does not. Okay, so my RabbitMQ admin will be Shekhar. So since I created the user with the name Shekhar. Okay, so this has been set. So as I mentioned, there will be a default user with the username guest, so I need to delete that since we will not be requiring that. So that will be my RQ RabbitMQ CTL delete hyphen user, and that will be my GUEST guest. So the user is deleted. So let me list the user RQ and list hyphen users. So here we can see I have a user with the name Shekhar, and the tags associated with this is administrator. So far so good. So let's create a RabbitMQ virtual host. So for that, let me add a virtual host and cherry broker. Okay, no issues. So we added a host with the name cherry broker, and let me list the virtual host. So here we can see we have a cherry broker virtual host, and as we can see there are currently two available virtual hosts / and cherry broker on our server. So we need to delete the virtual default host. So for that, RabbitMQ CTL delete the host and the host name. So the host name will be /. So if we list the virtual host, we will see there is only cherry broker. So we are good to go. Let me clear this. Now as I mentioned, we need to provide user permission on virtual host as well. So for that, let's set the permission for this. So RabbitMQ CTL set _permission permissions -p and cherry broker, and my username is Shekhar, and I need to provide the permission. So this will be for configuring. This will be for read, and this will be for write. So the first one permission that we allowed will be for granting configuration permission, the second will be for write permission, and the third will be for read permission. So we are allowing all three permissions for this user for this host. Okay, so setting permission is also successful. So let us list RabbitMQ CTL list permissions and -p, and my host is CHERRI broker. So we could see the listed permission for this one. List PRMISSIONS. Okay, so we could see for the user Shekhar there is all three permission associated, that is configuration as well, right, and the read permission as well. So we are good to go. Now if we go here and if we refresh this, and if I try to log in with the username Shekhar and my password is password, so here we can see we are successfully logged into the dashboard of RabbitMQ. So currently these are the basic things that been provided here. So we can also see the sound statistic, we can see the ports and context associated with this. So AMQP will be requiring this port to be open, so we also need to add this over our security group. So we are good to go. Now we'll be sending and consuming RabbitMQ messages in Python. So for that we need to install a package within the Python. So there are many SDK available for RabbitMQ. We'll use Python for this tutorial, and first we'll be installing Pika. That's a Python client that is recommended by RabbitMQ development team. So we'll be using pip to install Pika. So for that, pip install Pika -- upgrade. Okay, so looks like pip is not installed. So pip apt install Python 3 pip. Okay, so I want to continue. Yes. Okay, so I'll be cloning this repo in my machine so that I could utilize the code that I have written for the producer and consumer. So the code itself is descriptive. So as I have added the comments within each sections, so what we are doing and what's the kind of thing that we are trying to do. Okay, so as I mentioned, we need to open this port as well. So I'll be adding this port 5672. Security, let me go to the security group and let me edit inbound rule and let me add a rule and 5672 for AMPQ. So this is done. So this is also done. So let me clear this. We are good to go now. Now let me install the pip install pika -grad. So this will be installing pika. Running pip as the root can result in. Okay, so pip install pika -upgrade upc requirement already satisfied. Pika is on this location, so we are good to go. Now let me clone the URL here. So git clone. Okay. Okay, so the code is also pasted here or the cloned here. Sorry, alias. So we could see there is a RabbitMQ producer consumer. So let me go to RabbitMQ producer consumer. Let me clear this and let me list out the file. So there are consumer.py and producer.py. So first and foremost, we need to produce the message. So we'll be running or we'll be executing this producer.py. But before that, we need to change certain configuration according to the configuration that we did while installing the RabbitMQ. So for that, let me go to producer.editor and let's go here. So here we can see the username is set to the big rabbit, which is not in our case. So the username will be Sekhar. So I think the apostrophe is something missing here. And the password, as you know, we have set the password as password itself. And the virtual host is set to cherry-broker, not _broker. So this will be also causing trouble. And the port is 5672, which we just opened over the security group as well. And talking about the host, so since this is over the same server, so I can also add the IP of this server itself. So I'll be adding this. Okay, so we are good to go now. So let's run this. So for this, Python 3 producer.py sent hello world. So the message is been sent successfully. So if I come here and if I refresh this, so here we can see the queued message is set to 1. So the ready message is set to 1. So within queue here we can see there is a message coming from the virtual host Cherry broker, and the message name is hello, which we just executed, and it's ready. So it's produced but is yet to consume. So in order to consume, we need to also run the consumer file. So let me clear this and let me and open the consumer.py file within my editor. And the same thing goes for here as well. So the password will be password and my username will be Sekhar and Cherry hyphen broker and port 5672 and the IP address. Let me paste the IP address. I think I left one space here, so we need to add one of the space here. So we are good to go. Let me save this. Let me clear this and let me run this python 3 consumer.py. So here we can see waiting for the message to exit. Press Ctrl C and here we can see received hello world. So the message is being, so here we can see the ready is set to 0 and this message is being consumed. So if I go here over the overview and look at the graph, we could see there was a message for certain time where the status it showed to queued message showed to 1.0 and later after some time after the message got consumed we could see it's dropped down. So in this way things work out on RabbitMQ. So in this guide we have learned that how RabbitMQ works, its advantages and possible use cases as well. So this is the same possible use case that we set in the enterprise setting as well. So there will be always be a producer which will be producing the message and there will be a list of consumers over the queue which will be consuming the message provided. So we can now continue developing further to implement our desired message broker use case in the production environment according to the similar way out that I just saw here. So yes, thank you for this video. So if you have any queries or any kind of question, you could please share this over the comment section itself. So I'll be reaching out to you and we could further start digging into it as well. So yes.